equal to 0, and then I'm going to subtract 1 to get x squared by itself, to solve it by square roots, and then I take the square root of each side. What's the square root of -1? I. So plus or minus I. Do I have 3 answers there? All right, 0 is one of them. That's the real answer. And then we have these 2 complex solutions. Positive I is one, second answer, and then negative I is the third answer. So there are 3 answers there. What does the graph of x cubed plus x do in terms of the x-axis? I'm kind of trying to relate this to everything we've done this week. Yeah, you remember the zeros or the x-intercepts or the roots, all the same thing? What does the graph do for the 0? It crosses the x-axis because the multiplicity on 0 is 1, right? It only happens once. So that's an odd multiplicity. So that means it's going to cross the x-axis at 0. Does the positive and negative I have anything to do with the x-axis in the graph? No, because they're what kind of solutions? Complex. Complex solutions, you don't see them on the graph. You only see the real solutions on the graph. So this one would just cross the x-axis at 0, or the origin in this case. Let's look at this one. 4x to the third minus 7x squared is equal to 3x squared. We'll solve that by factoring. First step. Yeah, subtract the 3x squared to get like terms together and to get it equal to 0. 4x cubed minus 10x squared. It's in descending order now. 2x squared. Yeah, I got to have x squared, so that's going to leave us 2x minus 5 in parentheses. And will either of those factor further? Yeah. 2x minus 5 factor further? Well, I'm asking, will it factor before we're solving? We're not solving yet. We're just factoring. So 2x squared, there's nothing else. It's a monomial. It can't factor. And then 2x minus 5, it doesn't have an exponent on the x, so it's not a difference of squares or a sum of cubes or a difference of cubes. So it won't factor any further either. So we set each factor equal to 0. And then divide by 2. X squared equals 0. Take the square root. Technically, it's plus and minus in front, but there's no such thing as plus or minus 0. We just know the answer is 0, but it has a multiplicity of what? 2, because it came from an x squared. So we're going to say x equals 0 with a multiplicity of 2. And then the other one, we're just going to solve it for x. So 2x equals 5. And I'm okay actually with you doing that part in your head. You know, a lot of us can just go ahead and solve. 2x minus 5 is equal to 5 over 2. Now, let's relate that back to the idea of the graph. What is the graph doing at 0? Bouncing off the x-axis, because the multiplicity of 0 is what? 2, which is an even number. Okay, so if the multiplicity is even, it's going to bounce off the x-axis. What's it doing at 5 over 2? Crossing the x-axis because the multiplicity is odd. It's 1. What polynomial am I graphing to check that with? The one that's equal to what? 0. So if I'm unsure, or maybe I just need a hint and to help me get this right, if I pull out the calculator and graph, I want to graph the one that's equal to 0. So instead of putting 0 there, I'm going to treat it like it's y and graph that polynomial. No, not this one. Not a legal calculator. You can't. They make them that do it. Illegal for this class, ACT. end of course test, any college class that you take, they're not 4x raised to the third minus 10x squared. The graph, we see exactly that stuff happening. There at 0, we're bouncing off the x-axis, and then here at 2.5, which is 5/2, we're crossing the x-axis. So all of the stuff that we're doing relates together. It's not, it's none of it is separate. It's all together. Indeed, cumulative is a good way to describe all the math stuff. Let's do number 3. X to the 4th power minus 64 is equal to 0. Difference of squares, it's equal to 0 already. It's in descending order. It's got 2 terms and a minus sign in the middle. The exponent's even, so that's what makes me think about difference of squares. So what squared is x to the 4th? X squared, right? And then what squared 64? 8. So my factors are x squared plus 8, x squared minus 8. Will either of those factor further? No. This one would be the only one that had a chance because it's x squared minus a number, but 8's not a square number, so that's how we know that doesn't factor. So what do I do with them if they won't factor? Put them equal to 0 and solve. So x squared plus 8 equals 0. X squared minus 8 equals 0. And solve them up. So it's going to be x squared equals negative 8. Take the square root of each side. So plus or minus. And then we break down the 8. It's 4 and 2. Pair of 2's. So it's 2. And then because it was negative, what else comes out? An I radical 2. Positive 2i radical 2, negative 2i radical 2. So that's 2 of our answers. We got 2 more to find from the other equation. That's going to be x squared is equal to positive 8. Take the square roots. Plus or minus 2 radical 2. Does this graph cross the x-axis or bounce? Which one? All the answers are complex? No, just the ones with the I are complex. So the 2 radical 2 is a real answer. It's a decimal, right? 2 times the square root of 2, or just the square root of 8. So we've got how many places this thing crosses the x-axis? 2 places, because positive 2 radical 2 and negative 2 radical 2. The complex ones don't have anything to do with the x-axis. They're just solutions to complex solutions. All right, let's look at this one. 5x to the 5th minus 60x equals 20x. 5x to the 5th minus 60x equals 20x. First step. 20x, move it over. 5x squared, or 5th minus 80x equals 0. GCF, what is the GCF? 5x, what's that leave in parentheses? What times 5 gives me 80? 16. Will either of those factor further? Yeah, the x to the 4th minus 16 is a what? Difference of squares. So that's x squared squared, and 16 is 4 squared, right? So we're going to have 5x x squared plus 4, x squared minus 4. Will any of those factor further? That x squared minus 4 is also a difference of squares, one we're more familiar with. So we have 5x, x squared plus 4, And then what are the factors for x squared minus 4? Yeah, x minus 2, x plus 2. So now we've got it all factored completely. So what do we do with each factor? Set it equal to 0. So we have 5x equals 0. We have x squared plus 4 equals 0. X minus 2 equals 0. And then x plus 2 equals 0. So I'll go down there to get a little more room. Pretty easy solve on most of these. X equals 0. X equals 2. X equals negative 2. And then that last one, subtract 4. X squared equals negative 4, and then we take the square roots. Square root of a negative will be plus or minus 2i. How many times does this one cross the x-axis? 3 times. How many solutions do we have? 5. We got 0, positive 2, negative 2, positive 2i, negative 2i. One of the most common things that I saw on that quadratics test that you guys did is the fact that folks forgot when they took the square roots to put the plus or minus. If you don't put it there, then you're only saying it's a positive one. So if you didn't put plus or minus in front of 2i, you're just saying it's 2i, not the negative 2i. So that's missing half of that answer. So it's got to be there. You got to be very mindful of that. Attention to detail is important. Number 5. Let's get into some of that new stuff. X cubed plus 125 is equal to 0. What is that? The sum of cubes. And so we learned yesterday how to factor the sum of cubes. We rewrite that as the sum of 2 cubic things. So that'd be x. And what cubed is 125? 5. We're getting kind of familiar with our cubic numbers. And then when we factor that, there's a short factor and a long factor. So what would the short factor for this one be? X plus 5. The long factor would be minus 5x plus 25. There's always the opposite sign in the middle of the long one, that it changes the sign. And it's the product of the two things, 5 and x. And then the last one, that's from 5 squared, where that came from. Okay. Now, will this one factor any further? Remember we talked about yesterday, it never does. You could try it. You could try the x method if you got that fact. If you try the x method, there's nothing that multiplies to be 25 and adds to be negative 5. It just doesn't work. But if it's a sum of cubes or a difference of cubes, you can go ahead and rest assured that thing's not going to factor. Okay? So since it doesn't factor, what do we do with each of those pieces? Set them equal to 0 and solve. So we got x plus 5 equals 0. And x squared minus 5x plus 25 equals 0. So we get x equals negative 5. And since that dude won't factor, how do I solve it? Quadratic formula would be a great option. What would be another option? We're going to do quadratic formula, but there's another option. Complete the square would be another option. Okay, I'm going to do quadratic formula just because it's a formula and you just got to plug stuff in the right spot to get there. So if we're going to do quadratic formula, we remember that that's x equals negative b plus or minus b squared minus 4ac divided by 2a. All right, so all of that stuff. So I'm going to find the discriminant first, which remember the discriminant is the part underneath the square root. So negative 5 squared minus 4 times a times c. So that'd be 25 minus 100, which is negative 75. So the discriminant is a negative number. What does that tell us about the solutions to that quadratic? They're going to be complex, which means what about the graph? It's not going to show up on the x-axis. There may be a little change in direction or a little squiggle in the thing, but it's not going to touch the x-axis for those. So the only place this original polynomial is going to cross the x-axis is at -5. So that's what we're kind of trying to relate all this stuff back and tie those things together. So set up your quadratic formula. (b plus or minus the square root of -75 over 2 times a, which would be 2. So we're going to break down that 75. 3/4, pair of 5s. So that's going to be 5 plus or minus what? 5i radical 3 all over 2. Or you could split it apart. Some of us, we like doing this. This one really doesn't help us to split it apart because nothing simplifies. But you always kind of want to look to see if something might simplify out of there. We'll get to some that actually do. But not too crazy there. All right. So sum of cubes, it did not factor. The quadratic didn't. So we had to use quadratic formula to solve. That's definitely something we got to be able to do. Let's look at number 6. 5x squared plus 8x to the 5th is 4x squared. What do we do for this? Okay, in descending order, also we need to do what? Get the 4x squared on the same side with everything else. So I'm just going to do all of that in one step because I think we're definitely able to do that. So I'm subtracting 4x squared from the 5x squared. And then when I write my next line, I'm going to put the 8x to the 5th in the front plus x to the 2nd. And that's now equal to 0. So I got it in descending order. And so now I do what? GCF, which is x squared is 8x cubed plus 1. And will that factor? Because it is a what? Sum of cubes. What cubed is 8x cubed? 2x, and what's cubed is 1. 1. Okay, so we can rewrite that as a sum of cubes, so that means it factors. So we got the x squared that was in front, and then we got a short factor and a long factor. What's the short factor? 2x plus 1. Now the more difficult part, the long factor. 4x squared minus 2x plus 1. The pattern that we learned yesterday. It's always going to be square. If you rewrite it like this, the first term is always square the 2x or square whatever's cubed in front. The second term is always multiply them together. 2x times 1, make the opposite sign. The third term is always square this. And that's 1 squared, which is still 1. Always, you got to learn that pattern. Now, what do we know about that long factor? I'm going to have to use the quadratic formula to solve it because it's not going to factor any further. So I'm not going to waste my time trying to do that. I'm just going to set x squared equal to 0, 2x plus 1 equal to 0, and 4x squared minus 2x plus 1 equal to 0. Take the square root. X equals 0, but what do we know about it? It's a multiplicity of 2 because it came from an x squared. We know if we were to look at the graph of this, we'd see it bouncing off the x-axis at 0. either bouncing down and off of it or up and bouncing back down. And then the second one would be x equals -1/2. What's the graph doing at -1/2? It's crossing. It's going through the x-axis there. Crosses it. Now we need to do the hard one. So it's or the longer one. It's not very difficult, but it's longer. So I'm going to do the discriminant. So that'd be -2 squared minus 4 times a times c. It'd be 4 minus 16. It's -12. So we know that factor ends up giving us complex solutions. And so we'll just find those complex solutions. And so we're going to break down the 12. 6 and 2, 3 and 2. There's a pair of 2's that comes out along with what? I. So that's 2i radical 3. All that over 8. And we know that all 3 of these numbers are divisible by what? 2. So I could simplify that as 1 plus or minus I radical 3 over 8, or over 4, excuse me, or split it apart into 1/4 plus or minus I radical 3 over 4. Either of those ways of expressing that are fine with me. But how many solutions were we supposed to get? 5. Where are they at? All right, so 0 and 0 again. -1/2. Over 4, and then the 1 minus. That's our 5 answers out of that. So once you get to the end, go back, make sure you got all of the answers. You know the degree should tell you how many answers you found. So use that as a checking spot. Also, don't be afraid to grab your graphing calculator and graph the polynomial that's equal to 0. If you graph that, it's going to help you know if you got them right or not. Relate the things together. Tie that stuff together. It's not anything, I'm not trying to play tricks on you or anything. I want you to tie those things together because it'll help you when we get to problems that won't factor later on. Tying together the idea of the graph is going to help us. Let's look at, let's do this one. X to the third minus 216. Done a couple of sums of cubes and throw in a difference of cubes there. How do I know that's a difference of cubes? All right, the X has a cubed on it. That's a good clue. And then 216 is what? Cube. 6 cubed. And as you get more experience with this stuff, you get better at recognizing the cubic numbers and what you can do. One of my students Monday night at Parsons was asking me about, how do you know what to do with every problem? And I didn't really know how to answer that other than to say, well, how does your car mechanic know what to do when they're working on your car? They've got a lot of experience at that. They've learned certain things, do certain functions for a car, and if it's making this sort of noise, it's probably that. So they check there first. So when you're doing math, when you look at this, you see an x cubed, like Sweeney said, you got an x cubed there. So that's a clue that it's a difference of cubes. So I then start looking at 216. I may not remember 216 as a cubic number, but I know to check to see if it is, just because I've got experience with x cubed stuff out of that. So as you get more experience with this, you get better at knowing what to do. So let's factor that, dude. Short factor. X minus 6, long factor. Almost. Plus 6x in the middle. That'll make a big difference when we go to our final answer there out of that. And then what do we know about that long factor? It can't be factored. So we know we're going to have to do quadratic formula on that. So set each factor equal to 0. And the first one to get x equals 6. And I'm going to do the discriminant. So 6 squared minus 4 times a times c. So that'd be 36 minus 144, which is negative 108. Another negative discriminant. So more complex solutions out of that. Does it seem like a pattern is existing here in that long factor for differences of cubes? And sums of cubes seems to be that we're getting complex solutions every time from that. So let's look at the discriminant. So x negative 6 plus or minus the square root of negative 108 over 2. We'll break down 108. 9 and 12. 3 and 3. 4 and 3. 2 and 2. So you got a pair of 2's and a pair of 3's. That's going to be negative 6 plus or minus 6i radical 3. How did I get a 6 on the outside of that? Multiply that 2 and the 3 together from the pairs on my factor tree. Can that be simplified a little bit? Yeah. All of these numbers are divisible by 2, so I'm going to divide them by 2. So it'd be negative 3 plus or minus 3i radical 3. Technically, that's all over 1, but there's no sense in writing that. Just dividing by 1 doesn't change anything. So we got 3 answers. We got x equals 6, and then the negative 3 plus 3i radical 3, and negative 3 minus 3i radical 3 out of that. So difference of cubes mixed in there. And experience is key. We gotta do the practice to be, to know what's going on. All right, let's look at this one. X to the 4th plus 3x squared minus 42 is equal to 2x squared. What do I do with that one? Okay, got to get it equal to 0, so we're going to subtract 2x squared, x to the 4th plus x squared minus 42 equals 0. And then I look for a GCF. Is there one? No, but there are how many terms? 3, so that tells us to use what? The x method. So negative 42 up top, positive 1 on the bottom. 2 numbers that do that. 7, negative 6. Good job. Can I use the shortcut for my factors? Yeah, because there's nothing in front of x to the 4th. So I can use that shortcut. I know one of them's going to be plus 7 and the other one's going to be minus 6. But what goes in the front there? X squared, yeah. Will either of those factor further? Our only hope is the x minus, right? But that 6 is what is not a what? Square number, so we know it won't factor. So what do I do with those things then? Yeah, you set them equal to 0 and solve by square roots. X squared is equal to negative 7. Take the square root of each side, plus or minus in the front. I radical 7. And it's going to be x squared is equal to 6. Take the square roots. What do we know about the graph of that polynomial right there? What's it do around the x-axis? Does it cross the x-axis at all? Yeah, at the positive and the negative square root of 6. So it crosses the x-axis in how many places? 2, and the complex solutions, it doesn't show up. They don't show up on the x-axis. You're not going to see those. So we've got a 4th degree polynomial, so it's going to make that W kind of shape out of it, but it's only going to cross the x-axis in 2 places. If you always have the option of graphing the thing and looking at it. And zoom out a little bit so you can see that. Zoom out just a little more. You see, well, I zoomed out way too much right there. But we see it's crossing the x-axis at those 2 places. Right there, right there. And that's the positive and negative square root of 6. If you hit trace and did negative square root of 6 as your x value, boom, y 0. We see the connection between the graph and the factoring and the solutions. That's really my focus for this unit, is connecting all this stuff together. Because if you don't connect it, then it seems like such an abstract thing to do. But if it's all connected, it just makes more sense. Let's look at this one. X cubed minus 8x squared plus 16x. Go ahead and put it equal to 0. GCF of x squared minus 8x plus 16. Okay, x method on that. Multiply b16, add to be negative 8. Negative 4 twice. So that's going to be x and x minus 4 squared, right? So set x equal to 0, set x minus 4 equal to 0. That one's done. This one is x equals 4, but what do we know about it? Multiplicity of 2, because there were 2 of those. Not hard at all, right? Oop. Try this one. Let's go to the x to the 6th power, because it's fun. GCF of x squared. Is that all? There's a 2 that goes in that too. So that's going to give us x to the 4th minus 5x squared minus 24. And let's try the x method on that. Negative 24, negative 5. Almost. 3 and negative 8. Okay. You got to add to be a negative 5. So that's going to be x squared minus 8, x squared plus 3, and then the 2x squared that was already out there. Set all of those equal to 0, because the x squared minus 8 won't factor, and x squared plus 3 won't factor. So 2x squared equals 0, x squared minus 8 equals 0, x squared plus 3 equals 0. So on the first one, we know the 2 is going to cancel out. We take the square root. We know we get x equals 0, and it's a multiplicity of 2 because it was x squared. You know that from there. And then the second one, x squared minus 8, get that equal to x squared, and take the square roots of both sides. What's that simplify to be? 2 radical 2. Good job. And then the last one, plus or minus I radical 3. So what's happening at 0 for the graph? Bouncing. and what's happening at positive and negative 2 radical 2. It's crossing that x-axis. And then is anything happening on the graph with the complex? No. Okay. All right. 2 more and we'll be done. X cubed plus 2x squared plus 3x plus 5 equals negative parentheses 2x plus 5. All right. Yeah, that'd be a good idea. So trying to simplify and get it equal to 0. So on the right-hand side, there's a little bit of work to be done. So if we distribute, that's going to give us negative 2x minus 5. And the other side's the same. Now what? Yeah, add the 2x and add the 5 to get the like terms together. So now we have x cubed plus 2x squared plus 5x plus 10 equals to 0. Say that again. Okay. Grouping, yeah, because it's got how many terms? 4 terms tells us to group. It's in descending order. There's not a GCF for the whole problem. So we're grouping first 2 together. Next 2 together. What's the GCF of plus 5x plus 10? Kind of 5. Positive, so it's plus 5 and then x plus 2. So our factors are x plus 2 and then x squared plus 5. And will x squared plus 5 factor any further? No. So set those factors equal to 0. X equals negative 2. X squared equals 5, negative 5. Take the square root. Plus or minus what? Radical 5. How many solutions should we have found? Did we find 3? Yeah, there's 3 of them there. Okay. Last one. 2x cubed minus 3x squared minus 32x plus 48 equals 0. Last one. So he said, it's too many. I'm done. 11 was my cutoff. All right, yeah, we can go ahead and group here because it's already equal to 0 and there's no GCF across the whole problem. There almost is, but the 3x squared messes that up. So GCF of the first pair is just x squared. Which leaves us 2x minus 3. And what we pull out of the second pair? Negative how much? Which one's the greatest common factor? 16. Both would be common factors, but we want the greatest common factor because that's the only way to get 2x minus 3 left in the parentheses. If you pulled out the 8, you wouldn't have the matching parentheses. So then we got 2x minus 3 and x squared minus 16. What do we know about the x squared minus 16? It's a difference of squares. So that's 2x minus 3 and then x minus 4, x plus 4. Ooh, that's nice. All really easy ones to solve now. Three over 2, 4, and negative 4. If I graphed the original polynomial, what would happen? It'd cross the x-axis at those three places. We would be able to check it that way. That's always a plus.